Okay, time for more interview practice. Differentiate x to the x. I'm going to say y equals x to the x, which means if I take the natural log of both sides, ln y is x ln x, and I can differentiate implicitly. So 1 over y dy dx is equal to, and then by the product rule, 1 plus ln x, I believe, which means dy dx is going to be this times y, so x to the x, 1 plus ln x. Integrate cos squared x and cos cubed x. Well, I know that cos 2x is 2 cos squared x minus 1. So the integral of cos squared x is equal to the integral of cos 2x over 2 plus 1 over 2 dx, which is equal to a quarter sine 2x plus x over 2 plus c. Now for cos cubed, I may want to use cos 3 theta perhaps. That may be the best plan of action. I know that cos 3x is equal to 4 cos cubed x minus 3 cos x. So that means cos cubed x is going to be, so we have the integral of cos 3x over 4 plus 3 quarters cos x. So this is going to be sine 3x over 12 plus 3 sine x over 4 plus c. So I think that should be good. What is the square root of I? Well, I know I is a fourth root of unity, so the square root of I ought to be an eighth root of unity. Thing is, I don't know which one. I could consider sort of the standard further maths method of finding the square root of a complex number. So if I consider a plus bi as the square root of I and square it, then I'll get a squared minus b squared plus 2ab, which means for this to equal I need a squared is equal to b squared and 2ab is equal to 1. So I could take, for example, a equals 1 and b equals a half. So one of the square roots is going to be 1 plus a half I. Wait, no, a and b need to be equal, or a is minus b. Never mind. Okay, so if a equals b, then we have a is 1 over root 2. So we could have root 2 over 2 plus root 2 over 2i. If a is equal to minus b, then we have minus 2 a squared is 1, which means we get a squared is root 1 minus 1 over 2, which doesn't have any real solutions. And when we specify a plus bi as a complex number, we need a and b to be real. So I think this is our only answer. If I had a cube and 6 colours and painted each side a different colour, how many different ways could I paint the cube? Okay, I would do this quite quickly, but I think we have a slight issue. If I draw out some cube, if I were to paint this side red, this side green, this side blue or whatever, and then the other 3 sides whatever, if I were to rotate this cube and still sort of see the same thing when I look at it from a fixed point of view, is that a different cube? I'm not sure what is the side, so I'm just going to say that it's 6 factorial. How many, so if I had n colours instead of 6, then it would be n p6. yeah, we have n possibilities for the first, then n minus 1, and so on up to n minus 6. So, yeah. Okay, integrate ln x, I can do that by parts. If I do the same, the integral of ln x dx, well, ln x is the same as 1 times ln x. So this is going to be equal to x ln x minus the integral of 1 dx. So this is x ln x minus x plus c. Sketch the curve, and I'm going to assume that says y squared minus 2 squared plus x squared minus 2 squared is 2. So we have x squared minus 2 squared plus y squared minus 2 squared equals 2. I may wish to expand out these brackets. First of all, I'm going to say that there's symmetry in the lines x equals 0 and y equals 0, because if you replace x for minus x or y for minus y, you get the same thing. I'm noticing this sort of something squared plus something squared is something kind of thing, which makes me think of circles, but this isn't in the standard form of a circle or anything. Well, I could just sketch this for the first quadrant, really. I do know that if x squared minus 2 all squared and also y squared minus 2 all squared have to both be greater than or equal to 0, which means if one of these terms is greater than or equal to 2, then we don't have any solutions. Well, greater than 2, then we don't have any solutions. So if x squared minus 2 squared is greater than 2, that means mod x squared minus 2 has to be greater than root 2. So, yeah, okay. So, either x squared is greater than 2 plus root 2, or x squared is less than 2 minus root 2, I believe. Yep. Okay. So this will be when x is so 2 plus root 2. Well, root 2 is approximately 1.4. So this is about 3.4ish. And this is going to be about 0.6ish. So okay. So root 0.6 is going to be between 0.6 and 1. So x needs to be between this square root of 0.6 and minus that, but it has to... Wait, hang on. Okay, so if I mark these as sort of the square roots of 3.4, then because this method applies similarly to y, we shouldn't get any solutions within this sort of annulus. I'm doing this really badly. I'm going to redraw my dots to make it a bit easier to work with. So if I plop these points here, or something like that, then draw our circles, then we should get no solutions in this annulus, I think. Okay. I think I'd like to check that a little. If I plug in 0 is 0, I'm going to get 4 plus 4 is 2, which obviously does not work. If I were to plug in maybe 4, then yeah, that. Wait, if I plug in something arbitrarily large, then that doesn't make sense. So, well, I've said it doesn't make sense. X needs to be less than... Oh, wait, yeah. So x needs to be less than 0.6. X squared needs to be less than 0.6. or x squared needs to be greater than 3.4. Oh yeah, so arbitrarily large things do work fine. Cool. Okay. So what do I want to say about where this graph does actually exist? I'm not sure. I could maybe, if I consider a circle with radius root 2 centered at the origin, then this is going to be the set of all points, which are sort of transformations from this circle. I may wish to complete the square, therefore. I'm not sure if that's worth it. I mean, if I do complete the square, then in theory I should just get transformations of a circle. So I probably would like to try that. I'm going to get that 2 is equal to, and then x minus 1 squared minus 1 squared, and then same thing, y minus 1 squared minus 1 squared. So this looks like it's just this circle centered at the origin, radius root 2, but in fact it's not centered at the origin. It's a translation of this circle? Actually no, I don't think that's how that works, because we're squaring and then squaring again. So, okay. I'm probably going to expand these brackets then. Yeah. So we have x to the 4 minus 4x squared plus 4. Yep. Then same thing for y, plus y to the 4 minus 4y squared plus 4 is equal to 2. Let's get rid of these plus 4s and we get equal to minus 6. I could well, there's no point in completing the square root of these two expressions because I'm just going to get what I got back to. I could consider sort of x plus 4 plus y plus 4 minus 4 x squared plus y squared is equal to minus 6. This is okay. This looks somewhat factorizable. If I were to consider something like x squared, then minus y squared, all squared, then this would be x to the 4 plus y to the 4 minus 2. Oh wait, that's still x squared y squared then, not x squared plus y squared. Okay, I'm not really sure what to do here. Do I want to maybe try find some points which are on the curve? If I want, I could say that these two things are both 1, so x is 3 and y is 3. Well, no, x is root 3 and y is root 3. Okay. Well, root 3 is going to be less than the square root of 3.4. Haven't I said that? That's... I'm not really sure. I'm going to move on. 3 girls and 4 boys were standing in a circle. What's the probability that the 2 girls are together but one is not with them? Okay, so 7 people in a circle. 1, 2, 3, 4, 5, 6, 7. Okay, so we have 3 girls, 4 boys. The 2 girls are together, but one is not with them. So essentially, probability that the 3 girls aren't together, given that they are together. If we place the 2 girls somewhere arbitrary, then we could place the 3rd girl in 3 more positions. So if this is fairly random, Okay, then I think out of the 5 positions the third can go, then we should get 3/5. Is it as simple as that? Maybe? I don't know. Prove that 1 plus, so essentially the harmonic series up to 1,000 is less than 10. Okay, so we are looking for the sum from r equals 1 up to 1,000 of 1 over r. And I could approximate this with an integral perhaps. So if I draw a quick sketch, if I sketch what 1 over r looks like, then at 1 we're going to have 1, at 2 we're going to have a half. So if I were to approximate this area, I could do rectangles like that, but that means, so that means my area must be an underestimate of what the actual sum is, and we need a less than inequality. So this works if my integral is an underestimate, so we get something like this. So this means we are integrating from 1 to, and then I believe 1001 from sort of fence post principles. 1 over, I'll call it r, RDR. So that means we are going to get ln 1001 minus ln 0, which is just, ln 1, sorry, which is just 0. And I guess we now wish to show that ln 1001 is less than 10. So e to the 10, I know that e is, I know that e is greater than 2. E to the 10 raised into the power of 10 is an increasing function. E is positive. That means e to the 10 is going to be greater than 2 to the 10, which I believe is 1024. So that means ln 1001 is going to be less than 10. So I think we're done. Is there such number n that this must be bad LaTeX formatting. I don't think I can tell what this is trying to say. I'm going to skip that then. I'm going to assume this is asking for the integral of x squared cos cubed x or cos 3x? I think cos cubed x. Okay. Integral of x squared cos cubed x. I probably would like to integrate by parts. So this is, I've got my dx. This is going to be x squared, and then the integral of cos cubed x I did earlier, did I not? Yeah. So x squared sine 3x over 12 plus 3 sine x over 4. Yeah. Then minus the integral, or, well, I might as well say 2 times the integral of x, and then this entire thing. So x sine 3x over 12 plus 3 sine x over 4 dx. And just for the sake of writing, I'm going to sort of move this down and say this is minus 2, and then we are going to have x so we need to integrate this now, so we're going to get, x then minus cos 3x over 36, I believe, and then minus 3 cos x over 4. Then we are subtracting the integral of this. So I'm just going to add to make my life a bit easier. So we get this. Okay. Close bracket. Then I'm going to replace. Okay, let's write this as. I'll move it down, I guess, so that I remember it's there. So this is going to be plus 2x cos 36 over 36, which is just x cos 36 over 18. Then plus 3 cos x over 2. 3x cos x over 2. Okay. Then I need to subtract 2 times this integral. So if I again use my lazy technique of moving this down, we're subtracting 2 times, and then we're going to get sine 3x over 108 plus 3 sine x over 4. So that means we're subtracting sine 3x over 54 and subtracting 3 sine x over 2. Which is an absolute monstrosity. Part of me hopes that the answer, that isn't the answer. Okay. How many squares can be made from a grid of 10 by 10 dots? This I've seen and done a lot of work on. It should be 3025. So just to explain it briefly, if I do this here. Oh wait, 10 by 10 dots or 10 by 10 squares? 10 by 10 dots. Okay, so it should be 2025. So if we have our 10 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then that's essentially 9 unit squares, and we go up. So to form any square in our grid, we choose 2 horizontal lines and 2 vertical lines. So our answer is just n choose 9 choose 2 squared. 9 choose 2 is 45. So we get 2025, which is quite nice. Integrate tan x, that's learn mod sec x. I mean function derivative is slightly simple, I'm going to skip it. Prove that every number in Pascal's triangle is plus e. Prove that every number in Pascal's triangle is the sum of the 2 above it. Is that not just a definition? I'm gonna skip that. I think it's vague on what it wants. Integrate 1 over 1 minus ln x. Okay. So it doesn't look like there's anything sort of standard or trivial I could do here. I may wish to integrate by parts. It doesn't look like there would be any useful substitution here. If I were to use something like u is ln x, then I'd have to multiply by x. X is going to be e to the u. So I get something like e to the u over 1 minus u. I don't really think that helps me that much. I may want to try integrating this by parts with 1 times this. Let's see what happens if I differentiate 1 over 1 minus ln x. Then this is, of course, 1 minus ln x to the minus 1. So, okay, I believe it should be 1 over x, 1 minus ln x, all squared. Is that right? I should be multiplying by minus 1 over x, but we get the minus from the power. I think this seems right. So I don't think this is going to help me that much if I integrate by parts. I might as well try anyway, I guess. So this is going to be x over 1 minus ln x minus the integral of 1 over x 1 minus ln x squared. This really doesn't help me at all, it's just making the problem harder. In fact, I now have 1 over x, so this may be worthy of a substitution. This is going to be x over 1 minus ln x, then minus, so if I set u as ln x, then I'm going to have to multiply by x, which means that I get 1 over 1 minus u squared, which I think is quite nice. To integrate this is x over 1 minus ln x, then, so 1 minus u to the minus 2, so minus, but minus goes away, so I think this is just 1 over 1 minus u. I'm going to check that that differentiates back to that. We get I think it does. U is just ln x, so I think we should get x minus 1 over 1 minus ln x. Cool. Sketch x to the x. I've seen that before, I'm not going to bother. Prove 4n minus 1 is a multiple of 3. Okay. Well, that's just not true, is it? If n is 2, then we have 8 minus 1, which is 7, which is a multiple of 3. Am I missing something? That's just not true. How many ways are there of getting from one vertex of a cube to the opposite vertex without going over the same edge twice? This seems very graph theory focused, I think. If I draw a quick cube, so from one vertex to the opposite, I think by opposite they should mean, for example, this one and this one, without going the same edge twice. I could consider this as a net, which would make this presumably easier to visualize. So if I try to imagine unfolding this, then I think this would go to that, for example, and there shouldn't be any loss of generality. Okay, so how many ways are there to get from there to there without going over the same edge twice? I have, if I draw my paths in red, I have one path there. How am I going to do this without making a mess? Okay, so I have one path there. I can go this path. Okay, I could also take the same path but then continue onwards. If I go left, up, okay, there are quite a lot of things to consider. What I could do is, let's say I get to this point, which I'm going to call point A, I guess. If I get to point A, then I can either go straight to the dot, I could do something like this, or I could do something like this. So I think that gives me 3 paths if I've got to A. I think that might help. Okay, so what I could count paths to A and multiply that by 3. So I could go 1, then 2, 3, 4, 5, 6, 7. I think that's right. So I should have 7 paths to A, which gives me 21 to contribute. Now I need to consider paths where I don't go through A. That's going to have 1, 2, 3, 4 paths. I think my answer should probably be 25 then. What shape would there be if the cube was cut in half from diagonally opposite vertices? Well, I think that's going to be like a sort of wedge kind of thing, like a 3D trapezium, if you will. I think that's reasonable. I'm not sure, I'm bad at visualizing this kind of thing. Draw y equals x, ln x. Let's do that somewhere over here. So, y equals x, ln x. Have I already done something with this? I feel like I've already done something with this. Oh yeah, well the derivative of this is going to be 1 plus ln x, which might help. Well, ln x can't be minus 1. Yes, it can. So if x is 1 over e, then we have a stationary point. Oh, ln x isn't defined for x is less than 0, so I can just consider positive values of x. So when we have 1 over e, we have a stationary point. Y is going to be 1 over e times minus 1, so the stationary point is going to be negative. Okay. So, as x tends to infinity, both x and ln x tend to infinity, so y is going to tend to infinity. I can't consider x equals 0, but I could consider as x tends to 0, which is going to give sort of 0 times minus infinity, which doesn't really work. What I could do is write y as ln x over 1 over x. So now, as x tends to 0, the top tends to minus infinity, and the bottom tends to infinity. So that's an indeterminate form. So I can use L'Hopital. So the limit as x tends to 0 of y is the limit as x tends to 0 of 1 over x divided by minus 1 over x squared. So this is just going to be minus x. So the limit is going to be 0 as x tends to 0. I would try to show that that isn't actually a point in my domain, but I don't really care. There's going to be a root at x equals 1. So let's plot that here. And I think that's enough information to show that our graph does something like that. Okay. Integrate and differentiate x ln x. Well, I've just differentiated it. I guess it's time to integrate it. So the integral of x ln x, I probably want to use parts. So this is going to be x squared over 2 ln x minus, where's that, equals, minus the integral of ln x. No, what am I doing? X squared over 2 over x, so x over 2 dx. So it's x squared over 2 ln x minus x squared plus c. Draw sine 1 over x. I've done that before, I'm not going to bother. Differentiate x to the x to the x. Really? Okay. Let's do this then. X to the x to the x. Well, I know that the derivative of x to the x from earlier is x to the x 1 plus ln x. So if I chain rule, then the derivative of x to the x is going to be, well, I know that the derivative of, okay, so, okay, this is going to be x to the x times x to the x minus 1 times x to the x 1 plus ln x. I hope that's right. That is very messy and I don't really like that. What do you know about triangles? A lot. I'm not going to bother to answer that. Find a series of consecutive integers such that the sum of the series is a power of 2. 2. That surely counts. I'm sure they want more. Okay, I know that 2 to the n is the sum of binomial coefficients. Unfortunately, there aren't exactly sort of binomial coefficients. Wait, okay, so I could sort of work with that. For example, I know that 1, 4, 6, 4, 1, when you add them is going to give you 2 to the 4. So I could consider how I can sort of collect consecutive integers from this. I wish to make a 5 here, I guess. Or I could go for a 7. Don't really think that works that well. If I try 1, 3, 3, 1, then I don't think this is going to work very well either. If I go 1, 5, 10, 10, 5, 1, yeah, I don't see how I'm going to get consecutive integers from this. What I could consider is if I have an odd number of consecutive integers, then the mean is just going to be the middle one times how many there are. So I need that to be a power of 2. So if I choose, say, let's go 32, then if I have, actually no, I'd like something that's, okay. So if I go a total of 32, then I could say, wait, that isn't going to work because I'm going to have an even number of numbers in my list, I think. Okay, I'm not sure if that's going to work then. Find a series of consecutive integers such that the sum of the series is the power of 2. 0 plus 1 also works. I mean, it's a very vague question. I'm just going to move on. I have no idea what Ptolemy's theorem is. Might as well search it up, I guess. Some circle theorem. The product of the lengths of the diagonals of a cyclic quadrilateral is equal to the sum of the products of the lengths of its opposite sides. Yeah, I cannot be bothered to try to prove that. Find the roots of the equation mx equals sin x, considering different values of m. Well, if I sketch a graph of sin x, okay, we are considering a straight line from the origin. X is 0 will always be a solution. Well, I know that sin x is approximately x when x is small, so I assume if m is greater than 1, then there are going to be no solutions. Apart from x equals 0, in fact, so just only sum is x equals 0. Okay, I guess if we only consider positive m for now, if m is really small, I may be able to get more solutions. I know that any solutions I get when x is greater than 0 will also be solutions x is less than 0, just y is negative. So I think... Do they want us to find solutions or how many? I don't think there's a sort of analytic way to find what the solutions are. So I think in theory, if M is small enough, this can intersect effectively infinite times. I know that if M is 0, there's infinite solutions. But in theory, yeah, I mean, it does depend on what M is, if M is between 0 and 1, to see how many solutions we get. Okay, if M is negative, then it should just be the same idea. So if M is less than 1, in fact, we now need M to be less than sort of this tangent. This point is 3 pi over 2 minus 1. So the gradient... So I think M needs to be less than minus 2 over 3 pi to get one solution. And I think, apart from these equality cases when we get two solutions, I think in most other cases it really depends on what M is to see what solutions we'll get. Integrate mod, is that sine to the n of x or sine nx? I'm going to assume it's sine to the nx. Okay, so sure. Let's start with mod sine x cos x then. No, mod sine x plus cos x. Then this is from 0 and I assume 2 pi. So from 0 to 2 pi. Okay, so I know from harmonic form that this is the same as root 2x, I believe, plus pi over 4. So we're integrating this, root 2 sine x plus pi over 4. So we're integrating mod of this. So if I do a quick sketch, then we sort of shift everything to the left by pi over 4. So that's going to be 2 pi and yeah. Well, we only really need 0 to 2 pi. So if that's 0 and that's 2 pi decimal, then our mod of this is going to be more like this. So okay, so the root of this that we're interested in is going to be when x is 3 pi over 4. So I think the integral of this should just be root 2 times the integral of sine x plus pi over 4 dx, then minus root 2 times the integral of sine x plus pi over 4 dx. This first one being from 0 to 3 pi over 4, and this second one being from 3 pi over 4 to 2 pi. So this should be root 2, and then minus cos x plus pi over 4 from 0 to 3 pi over 4. Okay, so minus cos pi is going to be 1, then minus cos pi over 4 is going to be plus, so it's going to be minus root 2 over 2 will be plus, so root 2 then 1 plus root 2 over 2, then minus, then the exact same thing 2 pi plus pi 4, so that's going to be the same thing as root 2 over 2. Then that we just had was, wait, no, sine integrates the minus cos, so minus root 2 over 2, so plus root 2 over 2, then minus, we're going to subtract, so we're going to add minus, so 1 minus 1, I think. This should be right. I'm going to very quickly check again. Minus cos that, so this pi is minus 1, so 1, subtract 1 plus, we plus 1. So we get root 2 times 2 plus root 2, so that's 2 root 2 plus 2. Okay, now what if it's mod sine squared x plus cos squared x? Well, I know that that's just 1. And also, because they're sort of terms squared, then they're always greater than or equal to 0, so I don't need to worry about the mod. So, just 1, I think, from 0 to 2 pi, so that's just going to be 2 pi. I'll just write that down somewhere here, for n equals 2. Cool. If x squared plus y squared is z squared, prove x, y, z is a multiple of 60, and I'm going to presume that x, y, and z are integers here. Okay, interesting. I know an example of 3, 4, 5, a Pythagorean triple. 3 times 4 times 5 is certainly a multiple of 60. So how did I go about proving this? I could consider possible residues of squares mod 4. I know that they have to be 0 or 1. So, okay. So, x squared plus y squared is z squared. I know that each of these has to be congruent to either 0 or 1 mod 4. So, to get from sort of 0 or 1 plus 0 or 1 to get to 0 or 1, I can either take 0, 0, 0, so I'm going to sort of write this here, 0, 0, 0, or 1, 0, 1, without loss of generality, of course, because I can just relabel x and y as I wish. So, in the first case, 4 divides x, 4 divides y, and 4 divides z, which is, I think, a good thing to have established. In the second case, we know that 4 divides y, but we know that x and z leave a remainder of 1 upon division by 4. Okay, well, 60 is equal to 3 times 4 times 5? No? 2 times 3 times 5? No, what am I doing? 12 times 5, 2 squared times 3 times 5. So we need to prove that... Oh, okay, so this is good, because x, y, z, since it must contain a multiple of 4, that means we know that 4 divides x, y, z. So now we need to show that they can't all be odd. Well, an odd squared... Wait, that's not going to help. No, never mind. So we need to show that 3 and 5 both divide x, y, z. I guess I could consider everything mod 3 and mod 5 now. So, we have 0, 1, and 2 are the possible residues mod 3. Squaring gives 0, 1, 4. So, I might as well write mod 4 here just for clarity. Yeah, so each of these can be 0 or 1 mod 3. So that means we can either have 0, 0, 0 or 1, 0, 1 mod 3. In both cases, at least one of x, y, and z is divisible by 3. So we've shown that 3 divides x, y, z. Now, if we do 5, we have 0, 1, 2, 3, 4, which square to 0, 1, 4, 9, 16. Mod 5, these are 0, 1, 4, 4, 1. So we get 0, 1 or 4, then plus 0, 1 or 4 to get 0, 1 or 4. So we can either take 0, 0, 0, then 4, 0, 4, and I don't think there are any other possibilities. So that means at least one of x, y, and z is divisible by 5, which means we have shown that x, y, z is divisible by 60. Cool. Two people are playing a game which involves taking it in turns to eat chilies. There are 5 mild chilies and 1 hot chili. Assuming the game is over when the hot chili is eaten, is it a disadvantage to go first? Well, 2 people. So, if I go first, my chances of eating the chili are a 6, then plus, well, I don't eat the chili, and the other guy doesn't eat the chili, so 5, 6, 4/5, and then you do eat the chili, so a quarter, and plus 5, 6, 4/5, 3 quarters, 2 thirds, a half. So that should be the probability that I eat the hot chili if I go first. So I can do a bit of cancelling here, and I get, I think, a 6 for all of these, which is quite nice. So I should get a half is the probability that I eat the hot chili if I go first, which means there's no advantage or disadvantage of going first, I think. What is the probability that I will eat the chili if I go first? Yeah, a half. How about if there are 6 mild and 2 hot? Okay, so the probability I eat the hot chili if I go first is going to be 2/8, then plus 6/8, then 5/7, 1/6, then plus 6/8, 5/7, 5/6. No? Wait, no, that should be 2/6, yeah. So this would be 4/6, then 3/5, then 2 quarters, then plus 6/8, 5/7, 4/6, 3/5, 2 quarters, 1/3, then there's nothing left. So this shouldn't contribute anything. So this should be a probability. I can again cancel things. I get 3 times. Wait, no, I can't actually. Oh. So I get this. Oh, okay. So 10/56, or just 5/27, no, 28. Then the 6s cancel, 5s, 4s, then so 3/28. 2/8 is the same as 7/28, so this is equal to 15/28, which is slightly more than a half. So I guess I don't want to go first. Kx to the 4 is x cubed minus x. Find the real roots when k is 0. Well, 0, 1, and -1. Sketch the graph when k is small, then when k is large. Find approximations of the real roots in both cases when it's the sets of 3 real roots. Okie dokie. So if I draw x cubed minus x, then kx to the 4 if kx is very small, it's going to look something like that, but there will always be 3 intersections. Find approximations of the real roots. Okay, they're going to be very close to -1, 0, and 1, I think. If k is large, then we could get something like that, which gives just 1 root, which is going to be 0. When does x have 3 real roots? Maybe when k is negative. If I have something like this, then that also gives 3 roots. So yeah. Okay, sketch. F of x is x minus rx over. Is that supposed to be over 2? I can't tell, so I think I'm going to skip this. A plus b over 2 is an integer. Is the relationship transitive? So, by transitivity, I think that should mean if a plus b over 2 is an integer. Wait, what's the relation here? Adding and subtracting by 2. So, okay, if I define a function sort of f of ab is equal to a plus b over 2, and this is an integer, then if I do this plus something else over 2, then the first thing has to be equal to the last thing. I know the equivalence relation is transitive, because if a equals b and b equals c, then a equals c. But I don't see how I should be applying that to this. So I think I'm going to skip. What on earth? What on earth is this? I think this is trying to say 1 over 1 plus 1 over 1 plus 1 over and so on. How many times do I do this? So I should have 1, 2, 3, 4, 5, 6, 7, 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. So I have to differentiate this. This is a nightmare. Do I really? What do I even do here? I could just try chain rule multiple times, but I don't think I can be bothered. I could maybe differentiate implicitly. I really don't want to do this. Let's do, what time are we on? 15 minutes. Sketch the graph of 1 over x, 1 over x squared, and 1 over 1 plus x squared. Well, 1 over x, then 1 over x squared, then 1 over 1 plus x squared probably requires a bit more to it. I can complete the square, so 1 over x plus a half squared minus a quarter. So that's just going to be 1 over x squared, but shifted left by a half and down by a quarter. So it's something like that, I presume. And I think I'm going to leave it there, having done 35. I'm tired.